In this lab I want to demonstrate how to do a V-belt or synchronous belt or a roller chain assembly and then put a belt joint on that in dynamic simulation. Let's see how to set this up. To find the assembly file and parts for this lab, I'll go to the Inventor 2015 dataset tutorial files, and in the Inventor 2015 mechanical design folder, if I double click on that and then tutorial files, I see this folder down here for V-belts. I'll go down to that folder, I'll open up this V-belts assembly. I'll put the link to these files in the description of the video. If we attempt to move these files, it's not readily apparent, but this shaft rotates. But if I try to translate, this doesn't translate or move in a straight line back and forth. So that position is fixed. If I drag this one though, this position is free to move. Let's open up one of these rollers or the shafts. So I'll do open, and I'm going to turn on the visibility of the YZ plane, and I'll turn on the visibility of the XZ plane. I'm then going to split the faces on this just so that we can clearly see it. So I'm going to do split, and I'll select this as my splitting tool, and I want to split those faces, and then I'll do split again, and I'll select this one, and I'll select that face and this face to split that. I'll then turn off the visibility of those work planes, and so I've split that into 4 faces. I'm going to change 2 of these faces to blue, so I'll go to the properties and I'll change that to blue, and I'm going to change 2 of these faces to yellow. I'd like to split those end faces as well, so I'll go back to my first split and I'll say edit feature, and for the face selection I'll select this face and this face. Okay, so I've split that, and then for the second split I'll do edit feature again, and I'll get my face selection. I'll select these 2 faces and these 2 faces. Okay, so now I have those split into 4 faces, and I'll go up here and with my eyedropper I'll pick up this color, and will select this face and hold down the control key, and I'll select that face, and on the other side I'll select those 2 faces. I'll accept that, and then I'll do the same thing for the yellow. So I'll pick up the yellow color with the paint bucket, I'll put it on that face and also this face and this face. I'll accept that. Alright, so I'll save my file. I'll go back to the assembly, so now when I drag this we can see visually that this one is rotating, and if I have to ground this one so I can rotate that. If I temporarily ground this part, and then I can see that I can rotate that. I'm going to unground that second holder. I'm then going to go to the design tab, and underneath V-belts I see V-belts, synchronous belts, and roller chains. I'm going to select V-belts, and I get a choice of a V-belt. If I click here, there are many different sizes. I'll just accept the first one. Then it asks me to select a planar face for the belt midplane. So I'm going to select this face, and we see a preview of 2 rollers on the screen. I can give it an offset if I would like to. I can change the number of belts if I want this to be 2 or 3 belts on here. And then here I'm given a choice of I can create a component, I can select an existing component, or I can just set it as virtual. And then under this option I can put in a fixed position by coordinates, fixed position by selected geometry, and then we'll look at these others in a few minutes. So that's what I'm going to do, is I'm going to do fixed position by selecting geometry, and I want that first one, so it's highlighted. I want it to be relative to this cylinder, and so it moves it up to that cylinder. If I click on this ellipses, we see the information for that belt, and we can set the direction of rotation. And let's go back there. We could change the diameter, can change a bunch of different dimensions in here. And then if I click on this down arrow, I'm given a choice of different types of pulleys. So if I have an existing pulley, I can select the existing pulley. In this case I'm going to tell it to select this groove pulley. And then for the second selection, if I go to the second selection, so then for the placement, I can drag this up here close to where I'm going to end up with the pulley, and I can, this time I'm going to tell it I want it direction driven sliding position. Notice there's also rotation driven, so if this pulley were to rotate, if that was the design intent for it to rotate around this one, I would select rotate. In this case I want it to slide along this plane, so I'll do direction driven sliding, and I will select this plane. Now this plane is in the green standoff, it's not in the roller because it has to stay parallel. And then if I want to change the size of these, I can either click on the ellipses and change the size, or I can just drag it to a size. Then I can also drag this one to a size, and I can drag the position. And notice that as I drag it, it hesitates. So it only stops in positions where you could actually purchase a belt of that length off the shelf. So it's not going to allow you to design with a non-standard belt length. Now if you wanted to add an idler pulley in here, you could click to add a third pulley in here someplace to put an idler pulley to take up slack. I'm going to cancel out of that. Once I've set the size of my pulleys, I can also change the direction of rotation, and I'll say OK to that to place my pulleys. It gives them a name. Let's turn off the visibility of this work plane. I'm going to put my selection priority on feature priority, and then I'll right click on this work plane and turn off the visibility of that work plane. And then I'll shift right click, put it back on, I think I'll put it on part priority. Alright, now this subassembly can still rotate back and forth, and so we need to constrain this subassembly to this pulley. So I'll do constrain, and I'll select this cylinder, and I'll select this axis on this cylinder, and that moves that over into position. Now we see that this rotates, but it no longer translates. And we see that this one rotates. We want these pulleys to rotate with these shafts. But it's going to be difficult to see the rotation unless we put some defining geometry on these pulleys. Look and see what the diameter of that pulley is, of the shaft. So I'll go to the inspection tab, and I'll do measure, and I'll measure that, and I see that it's 1 inch radius or 2 inch diameter. I'm going to open up this first pulley, and I'm going to do a new sketch on the XY plane, and I will draw a line up vertically, and then I'll draw a circle at the end of this line, and I'll draw a circle at the origin. I really want to see through this model. I'm going to come over here, and I'm going to do shaded with hidden edges. So I want to make sure that I don't put this circle up here into this edge. I'll dimension this diameter as 2 inches, and I'll dimension this diameter I think as 0.375. Let's make that bigger. Let's do that as 0.5. I'll draw another circle in here between these two, and I'm going to change this circle and this line to construction. So I'll change that to construction. I'll change this to construction, and then I'll dimension this circle, let's say, as 3.75. Okay, so I have this circle below that line. That was important. I might make that 3.5. Alright, then I'm going to extrude the larger circle. So I'll do extrude, I'll select the larger circle, I'll put it on cut, and I want to go through all, and then I'll make that sketch visible again, and I'll do extrude again. I'll select a smaller circle, and I'll put it on cut through all. Then I'm going to do a circular pattern of that. So I'll do a pattern, I'll select this smaller hole, I'm going to rotate that around the z-axis, and I'll say OK, and I'll turn off the visibility of the sketch. You may want to give this some other color. Save that. I'm going to put this back to shaded with edges, and I'll go back to my assembly. Alright, so we have this part. Now when I try to drag this, it doesn't rotate, but we'll take care of that in a minute. Let's go ahead and do something similar on this part. So I'll open up this one. I'll start a new sketch on the XY plane. I'm going to draw a circle 2 inches in diameter. I'll draw a line going up vertically. I'll draw a circle from here up to the end of that line. Change these two to construction. I will draw a circle at the end of that line. Say make that 1.5, and I'll dimension this circle. I'll make that 5 inches. I want to make sure that that is not interfering with this circle up here, and I'm going to move that up a little bit. Let's do 5.125. I'll go back to shaded with edges, and I'll do extrude. The smaller circle I want to cut through all, make that sketch visible, and I'll do extrude again. I'll select this circle, cut through all. I'll do a circular pattern around the Z-axis, turn off the visibility to my sketch, make the part a different color if you would like to. I'll go back to the assembly. Alright, again, if I try to rotate this, it doesn't rotate. So this V-belt is a sub-assembly. So in order to make that so that we can rotate it, we need to right-click and set this to flexible. Now that that's a flexible sub-assembly, I can rotate this, and notice now that these two pulleys rotate together with the correct ratio between these pulleys. But I want these shafts to rotate with the pulleys, so I need to constrain a shaft to each one of these pulleys. So I need to find this pulley, and so that's this one, and I'll drill down until I find the planes in that pulley, and then I'll find this shaft, and I'll find a plane in this shaft to constrain to that. So I'm going to do the YZ, so I'll do constrain, and I'll do flush the YZ plane of shaft 1 to the YZ plane of pulley 1. I'll apply that, and then I'll close those two down. I'll expand shaft number 2, and I'll get the second pulley. I'll get the YZ plane of the second pulley to the YZ plane of the second shaft. Now when I rotate this, I see that the shaft rotates with the pulley. Now if we wanted to drive this in the assembly environment, we could put an angle constraint between the plane going through the shaft and this plane, and then drive that angle constraint. But let's take this over into dynamic simulation, and we will run it there. So if I go into dynamic simulation and I drag this pulley, I see that it rotates, and I see that this pulley rotates, but the motion constraint from the assembly environment did not get converted in dynamic simulation. I see that I have the two revolution joints over here as expected. So I'm going to go ahead and add the belt joint, and so I'll need to find where that belt joint is. So I will select a belt joint, and we see that we have two options here for a straight belt or for a crossed belt. So with a straight belt, both pulleys will move in the same direction. If they were crossed, then if one pulley moves clockwise, the other pulley will move counterclockwise. It asks me to select a cylinder for component number 1. Make sure that you select the same cylinder, either the top of the groove or the bottom of the groove, in which case we can't see it. If I selected down here at the bottom of the groove, I'm going to just select one of these circles, or you can select the cylinder itself. If you select a circle, it'll get the origin at the same time. So I'll select a circle, and then I'll go to component number 2, and I'll select the same circle on component number 2. It will automatically calculate the ratio between the size of those two circles, and I'll say OK to that. And now when I try to rotate this, we see that they rotate together with the correct ratio. If I want to play that continuously, I'll go to the revolution joint on the driving pulley, and I'll go to properties, 1 degree of freedom, revolution. I'll enable impose motion, and I'm going to do a constant value of 360 degrees per second. So then when I play this, I see that it plays. If I want to change that direction, there's two different ways I could do that. I could either put in a negative degrees per second, or I could right click on this revolution joint and go to edit, and I'll flip the Z axis on that revolution joint, and now when I play this, we'll see that it goes in the other direction. Let's play that for a little bit longer, let's say 10 seconds. Okay, so we see our pulley. Now if we want to get the graph of the velocity of these two pulleys, if I go to the output grapher, and for the two revolution joints, if I get the velocity for the one revolution joint, and I'll go and get the velocity for the second revolution joint. And so if this one's doing 360 degrees per second, this one's doing a little more than 212 degrees per second. If we want to change this to be a positive number, we've seen how we can do that. We can right click and go to curve properties and do an active multiplier, or we can do the same thing on this pulley that we did on that one with the revolution joint. I will edit, and I'll flip that Z axis, and I'll play this again. now we see that both of those numbers are positive values for the velocity of those two pulleys. Now we could record this directly to a movie, but we may want to do additional motions in Inventor Studio. And so notice that I have done 1,000 slides or 1,000 calculations, so we have to know what this number is right here. And I'll do Publish to Studio, and now I'm in the Inventor Studio environment. I'm going to set this to say do a 10-second animation, and I will expand the action editor, and I'm going to go to the animation favorites, and I see this simulation timeline is the animation favorite that was brought in from dynamic simulation. I'm going to right click on that, and I'm going to do animate parameters. You can also do that up here, and so I'm going to start at 0 and I'm going to go to 1,000. That was that number, the number of slides or calculations that we did. I'm going to tell that to occur, and I can put this at a different time period. If we calculate in dynamic simulation, it might not be real time because it has to do the calculations, but if I put it over here, I can change that time period to whatever I want it to be in Studio. And so now I'll go ahead and play this, and let's put it back to the beginning. Okay, so we see that rotation. Depending on the frame rate, it might not look exactly right. If you've ever looked at a fan or some other moving device and it looked like it was moving backwards when you know it was going in a different direction, that's the kind of visual anomaly that we sometimes see depending on the frame rate. Let's say that I want this to go in the opposite direction, and so I'm going to mirror that motion, and so now when I go up to this point, it will stop, and then it will go in the other direction. Maybe I want to do a turntable or zoom in on a certain portion of this, so I could tell it I want to create a camera view. I'm going to tell it to, I'll come over here and right click on camera and create a camera from this view, and then I'm going to make that camera active. And then here's our camera location, where its target is. I'm going to turn off the visibility of the camera itself. We don't need to see that. And maybe I want to rotate around and zoom in on some portion of this, and so I'm going to click on this to add this camera action, and so now it's going to rotate around and zoom in. Maybe I don't want that to occur until after this starts to go in the other direction, and so I'll rewind this, and let's move this down, and I'll play this. So it goes in one direction, and then it's going to, the camera is going to move around and zoom in into another direction as it rotates in the other direction. Maybe I want that zoom to occur a little bit faster, so I'll change the period in which that zoom occurs. We'll play it again from here, so it zooms, rotates around, and plays that action. So you can do a lot more types of animation operations in Studio after you've solved your mechanism in dynamic simulation.